Alright, 4.7 inverse trig functions. There's a few things I want to remind you about inverse functions in general that might help us in solving inverse trig functions. Now here's this function right up here. Y equals x squared minus 4. And its inverse is y equals plus or minus square root of x plus 4. If you were to find the inverse of this, you would find this. I'll save you the whole exchanging x and y and isolating y for another time. A few things to note. If we were to graph these, inverse functions reflect over y equal to x. The line y equal to x, meaning that diagonal, this diagonal right here, y equal to x, reflects right over that. Okay, that's one thing to note. Another thing it must do is your inverse function must pass the horizontal line test. Must, don't want to do that. Must pass horizontal line test. Meaning, remember the vertical line test way back in basic algebra? Whenever you can tell it was a function or not based off of whether there were multiple times on a certain vertical that it hit twice. Same thing with the horizontal. If you hit multiple times at any point over any horizontal line, you can't find the inverse. Okay, that's going to play a role into whenever we work through trig functions in a moment. All right, so here we got two poorly drawn trig graphs. We got y equals sine x and then y equals cosine x. Now here's where what I said last about the whole horizontal line test is important. What area in the sine graph is this to pass the horizontal line test? Only from here to here. Now there's other sections, but the ones closest to relevant areas is from here to here, which is what? Negative pi over 2 and pi over 2. And then for your cosine graph, where's it past the horizontal? From there to there. What's there to there? 0 to pi. So this is going to come into play when working with inverse functions, okay? Because your domain for your, the inverse sign is negative pi over 2 to pi over 2, and 0 to pi for cosine. Okay, so here's what the inverse of the three main trig functions look like. Keep in mind, we can write inverse sine, inverse cosine, inverse tangent like this. It could be arc sine, arc cosine, arc tangent, or just the -1 sign between the trig function and the x. So what the domain range? Domain for both sine and cosine will always be between -1 and 1, or including 1 and -1. The range for them is going to be different. The range is from negative pi over 2 to pi over 2 for sine. For cosine, it's going to go from 0 to pi. I should have put y for the other one. Let me fix that. Okay, and then over here, your domain is all real numbers for your tan, all reals, and then for your range, it's going to be in between negative pi over 2 and pi over 2. Think about it this way. If you remember what your domain range is of the original tan x graph, what would it be? The domain would be negative pi over 2 to pi over 2, and then your range would be all real, so it's swapped in this case. So we're going to find the three inverse trig functions of these three. Keep in mind, so you have to use your unit circle here, and you're working backwards, okay? Cosine, remember what we said. It's between 0 and pi, okay? So yeah, there are two x values that have 1/2. You're right. But your answer must be between 0 and pi. Cosine and tan inverse functions are between negative pi over 2 and pi over 2 and must be written as such. So you can't, if your answer ends up being 7 pi over 4, that's not a correct answer. You must be negative pi over 4, okay? So let's do a couple. So inverse cosine of 1/2. So where is 1/2? It is over here between 0 and 2 pi, right? And where is that? In radians. The answers need to be in radians, by the way. And that answer is pi over 3. Because x is equal to 1/2 right here. Arc sine of negative root 3 over 2. Where's that at? That's over here, right? How far backwards we go? We go negative pi over 3. And inverse tan of 1. Where's that? It's y over x. Where's y over x equal to 1? Right here. It's pi over 4. Those are your three answers. So your inverse cosine of 7 pi over 4. Some of us might want to cancel out the cosines and just say the answer is 7 pi over 4, but that can't happen because remember, that answer might not be in our possible range, okay? So cosine of 7 pi over 4, as we know, is root 2 over 2. Inverse cosine of root 2 over 2. Inverse cosine of root 2 over 2. Cosine is root 2 over 2 at 7 pi over 4. But remember, our answer must be between 0 and pi. So that means your answer needs to be pi over 4. Okay? Cannot be 7 pi over 4. That is not in your range. So a cosecant of inverse tan of 3 over 4. We need to solve this problem without a calculator. So remember, inverse tan of 3 over 4, we're going to be in the first quadrant because it's positive. Okay, so it's going to be in this first quadrant. Remember, tan is what over what? It's y over x. Okay, so it'll be 3, 4, and we need to find the hypotenuse. So it'll be 4 squared plus 3 squared equals c squared. You solve that, c is equal to 5. Okay, so we need to find out what cosecant theta is equal to. Cosecant is what? It is the reciprocal of sine, and remember sine is opposite over hypotenuse. So it's going to be flipped, not opposite over hypotenuse, it's going to be hypotenuse over opposite. So your answer is going to be 5 over 3. Okay, and that's everything. I appreciate you watching, and we'll see you later.